this question, which I hadn't put any marks down for some reason, but we'll do them now. So the first part of that, determine the frequency of the waveform in hertz and the period of the waveform in seconds. Well, you've got omega in the formula. Omega is 150 pi from the given formula. Therefore, you're also given omega as 2 pi f. Substitute that in, you end up with a frequency of 75 hertz.
Yeah.
75 hertz. Pi's cancel out, so there's 2 marks for that anyway. So if you've done some rearranging but ain't got the answer right, 1 mark. All right, and then the period is simply 1 divided by the frequency. So it's 1 over 75, which is 13 and a third, or 13.31 milliseconds. So that's 0.0133 seconds, or 13.3 milliseconds. Take either answer for 2 marks. The next bit, determine the phase angle. From the expression, you know that alpha is pi over 6 radians. In fact, that's minus pi over 6 radians. So you divide that by 2 pi, which is your fraction. Pi over 6 is the fraction of the whole circle, 2 pi, and multiply by 360. You might also do pi over 6 over pi and multiply by 180 degrees. Use the half circle method, doesn't matter. Same thing. Yeah. 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 However's best for you. Okay. But the answer is minus 30 degrees. 2 marks. I'll take a half a mark off if you don't tell me that's negative. Right? Because that is actually important. Yeah, I can. I can in certain circumstances give half marks. I've not done too much of that. No, I won't give a half, 1.5 rounded up to 2, Jack. No, I won't. Right?
There's lots of half marks. Round by half.
All right. Don't often find a need to use half marks, but sometimes. Okay? So, part C. When t is equal to 10 milliseconds, so we put a 0.01, the equivalent to 10 milliseconds, just plugging into the formula, calculating, you should get minus 3.25 amps. 2 marks. I believe. 3 marks I've given for that. 3 marks for that. If I realise that you've used the calculator wrong and you've had it in degrees, but you'll work the right answer out as though that was pi over 6 degrees, what?
I didn't take it to account with milliseconds, so I just put 10 seconds. How many marks do you get for that?
A mark if that answer's right.
Yeah, well,
It's no, but I mean, I can't, in all honesty, I can't give any marks for that, because that says 10 milliseconds, not 10 seconds. However, if the answer to that was being used in another calculation, and you correctly used that answer, I'd have to get my calculator out and calculate. I can't penalise you twice for the same mistake. That's not the case here, is it?
No.
You're not using it again, but so you would have lost the whole 3 marks there. I can't give anything for that. All right. And then the last part, you needed to calculate what half the peak is. So do 6.5 because that's the peak of a 2 to get 3.25. Plug that in the formula, and then do various bits of rearrangement around that to end up with a final answer of 0.0033 seconds, which is 3.3 milliseconds. Either of those two answers would do. If you haven't put the units on, lose a mark.
That's 6 marks.
That's 6 marks, that is. So if you hadn't got the right answer, I'd give various marks in stages through that question, okay? But again, if you use degrees instead of radians, I'm going to knock marks off for that as well, okay? There's 6 marks altogether for that. Must have units. Same with the previous question. It's amps. I need to have those units. I'll drop you a mark, okay? Not putting the degree symbol, drop mark. Maybe in some cases half a mark. Just depends on how many marks there are for the question. All right? Everybody happy with that? Yeah? Anyone not done very well at all with that question, or you're all right with that? Lewis had his moment with... Well, beyond 15 marks altogether. Beyond today, your revision is down to you. You know, and getting questions from the notes and having another go at them. The practice paper I'm going to give you, but it is down to you. There's plenty of examples you can find. There's stuff in the book, all right? And the extra examples I've given you in the notes that you may not. Even if you've already done them, don't get the answer out. Have another go. Same question, but if you don't look at what the answer is the first time you've done it, that's all good practice. Right, the second half of the paper is on complex numbers. So the first one is a short answer example. Carry out the following complex calculations, giving your answers in rectangular form. Okay. A, B and C are 2 marks each. D is 4 marks. For part D only, you may use conversion to rectangular form using your calculator. Okay. So we're starting that one at 12 minutes past. So we'll go 22 minutes past and then we'll do the answer. So, answers to this one. Part A. Add together 4 plus 7j and 3 plus 4j. Answer is 7 plus 11j, 2 marks. Add them together, 3 minus 6j and minus 5 plus 3j. Answer is minus 2 minus 3j, 2 marks. So if you don't get it, and argue with me if you think I got it wrong, won't be the first time. Part C, subtract 4 minus 6j from minus 7 plus 4j. Minus 7 minus 4 is minus 11. And plus 4 minus minus 6 is plus 10. Minus 11 plus 10j, 2 marks. Sorry? Be handy, won't it? But you're not. Okay. Then the last one was requiring you to convert those 2 polar numbers to rectangular. There's 3 marks for this, I think I said, didn't I? How many have I given to? 4 marks for this. So that's See at 45 angle 13 degrees. That one is the 38 angle minus 27. The final answer to three significant figures is 77.7 minus 7.13 J. Okay. Notice how I've used four figures here and then rounded. Is your calculator in degrees or radians?
Oh, bollocks. When you do that.
I deliberately did not say this time. I give you a warning the first time, right, knowing that this was coming up, and I thought I'll just leave it and see whether the ticking bomb goes off. Okay, so you're likely to get something for that if you've done it right, but not all of it. Okay, no more than half the marks if you've used degrees instead of radians, radians instead of degrees. All right. Okay, so that's that one, and as at least one person has saying we'll have 20 of them, please. I'm making the assumption that you're reasonably happy with adding and subtracting rectangular complex numbers. Check. Yeah, this is what I'm saying here. I've correctly rounded these conversions to four significant figures, one more than I'm giving in the final answer. Do you see what I've done there? Yeah? Because if that, and remember correct rounding, anything, you've got to look at the next digit, anything above 5 round up, anything below round down. Okay? If that becomes an exact number, put the extra zeros on to show that you've done it to those 4 digits. Okay? So if I round it up to 45, then put 45.2 zeros, that's four figures. You're showing you're using the same accuracy right through. Okay? Next question. Okay?
What's the last one? 29.7.
The final answer. 77.7 minus 7.13 J. If you haven't got that, the first thing to check is your calculator in degrees and not radians. Okay? So at your leisure, I would suggest you go through that question again, see if your method was right when your calculator's in degrees. Next question. Section B, short answer example 2. Carry out the following complex conversions, giving you answers to 3 significant figures in the request form. Should not use conversion to different forms in these calculations. So in the top, I'm asking you to multiply in polar form, then I'm asking you to multiply in rectangular form. I do not want you to convert that middle one to polar form and multiply. And I don't want you to convert that one to polar form and multiply. I want you to use the rectangular methods. Okay? Again, it's a 10-minute-ish kind of question. That's 11:27, so 11:37. Of course, in the exam, you might want to use that if you have time as a check, but I want you to show me the method to do polar multiplication, rectangular multiplication, and rectangular division. It is what I want, Paul. Everything's about what I want, isn't it? Have a look at it. Alright? Don't worry, you will not be disadvantaged. So the first one, this is the one there. Are you listening, guys? Jake has kind of pointed out, kind of didn't end up, we never calculated any voltages, otherwise we'd have certainly done multiplication with Ohm's law, right? So the method here is 32 times 3.5. So we multiply those two numbers together, and then that's an angle, and we add the two angles. So 17 plus minus 28. Answer is 112 at angle minus 11. Yes, 10 altogether, isn't it? So let me have a think here. Yeah, I'll give 2 marks. Okay. The next one, multiplying rectangular. First thing we've got to do is multiply the brackets. So minus 10 plus 8j plus 20j minus 16j squared. Key to this is remembering that j squared is equal to minus 1. Bringing that, so all that j squared does is change the sign of the final coefficient, and the j disappears, and the final answer is 6 plus 28j. 3 marks.
And you simplify it down to the square root of 28. Now let's get 11.3.
Why have you done the square root of 28 for?
Well, because I asked you to get to 3 significant figures. So I've gone to 28j, square root of the number 4, so it's the square root of 28 plus 6 and 11. No?
No.
But I still got all the marks because I've got 6 plus 28j.
Why you? I don't quite understand what you're doing. J is just a
It's asked for it for 3 significant figures.
yeah.
Yeah. So
But
that by itself is equal to the square root of 1.
yeah.
Yeah. So 28j is equal to the square root of 28. Yeah.
No,
No?
it isn't. It's that number means 28 times the square root of minus 1.
Oh right.
That's all. So if you got that, you got your marks, Dom. But you're overcomplicating it because I've asked for 3. The reason the 3 significant figures is in there is because of the last bit, part C. Okay. So here, the method is take that fraction and multiply the top and bottom by the complex conjugate. 6 plus 3j. So that's just this number here with the sign between them changed.
Yeah. True. True.
Oops. What's that?
Oh come on, Mike.
Okay, no problem.
I'll take it.
Right, gents, let's just go through the answer to this one, okay? So, all I've done in the first instance is put the complex numbers into the formula, okay? And then multiplied out the brackets, there, 2 marks for up to there, and another 2 marks for getting the complete fraction right, 27 minus 3j over 8 plus j. Then we are into multiplying by the complex conjugate. 2 marks for getting that bit. Okay. Multiplying out the top and the bottom. And I've just done it as a straight 8 squared plus 2 squared for the bottom because I know all the j terms are going to cancel. Okay. I've given 2 marks around that bit. Okay. And then ended up with the final bringing together of all these terms on the top here, there, and that answer there, 2, and an extra 1 for converting it to the right polar answer, 8.51 ohms at angle minus 67.3 degrees. Have I got the 2, 4, 6, 8, 10, 11?
I've got all of it right, apart from where you put 27, I've got 37.
How do you get 37, Lewis?
I just added, well, I didn't, obviously it doesn't add up, but I put 15 and 12 together and just
Made 37 instead of 27.
How many marks did you get there?
You might end up with a couple of 3 marks. That's difficult without reading it and see exactly what you've got.
The rest of it's all right, I think.
Well, yeah, we'll see, you know.
Same thing.
Yeah.
Minus 7.85.
51 over.
That's 0.8. That's
51 over 65. No, certainly isn't that. You're right.
It's 0 right there. 0.785.
0.785.
Yeah.
But does it work out to that or not?
I get 13.5 degrees. I get 3. I didn't get 3.5. What? 8.5.
What do you get there then?
Well, I get 3.48. 13 degrees.
Ain't gonna be that. Right. Section B, long answer example. The first bit asks you to determine both of the forces in rectangular form. So you can just use your calculator here to turn them into 20.84 plus 9.72J, 13.68 minus 13.2J. The reason I've done that is so I can add them together. Okay? Yes, just a simple calculator thing, 2 marks. That's 25. Yeah. These answers were created by me writing them on paper and scanning them, and they haven't come out that clear, unfortunately. Right. So the resultant is these two added together. So we add those two together, come out with that complex number, 34.5 minus 22.5J, and convert that to polar. So we got 41.2 newtons at an angle of 33.1 degrees. I would give, let me think. What did I give for the first bit? 2, didn't I? 4, I think. The last bit, right? What you're being asked here is determine the polar form of a third vector C that would make the resultant force overall, the new resultant, equal to 10 angle minus 90. What I've done here is converted that to rectangular form. 2 marks. Have I got to give for this 9 altogether? Right. Then, the new resultant is going to be the old resultant, the one you calculated in part B, plus the new force C. Yeah? Rearranging that, because we're trying to find this new force C, that's going to be the new resultant take away the old resultant. So there it is. There's the new resultant. There's the old one. Okay. So I'm going to give a couple of marks for getting to there. How many more have I got to give? 3, ain't I? Subtract that one from that one to come up with that, and convert to polar. 3 more marks for doing that bit. So what we're saying there is, if we add another force of 36.7 newtons at an angle of 160 degrees, the resultant would be a force of 10 newtons overall acting directly downwards. That's what that question was around. Yeah, I'll put it on the website. Yeah. Okay. So